Hi, my name is Carrie, and today I'm going to show you how to connect to the Mina Testnet. First, we'll need to set up our machine and install the necessary software to connect to the network. For the purposes of this tutorial, we will be using Google Cloud. The first step will be opening up the Google Cloud. Head to cloud.google.com and either create or sign in to your Google account. Once you've done that, you can then open up the console in the top right-hand corner of the screen. This will take you to your Google Cloud console, which will provide an overview of everything happening on your account. The first thing you'll need to do is create a new project. You can do this using the Projects dropdown and then selecting New Project. You'll also need to set up billing, but if you've never used Google Cloud before, you'll be given $300 credit that you can use, which is more than enough to complete this tutorial. The first thing we'll do is create a new virtual machine instance. Under the menu, select Compute Engine, and under the Compute Engine dropdown, select VM Instances at the top of the list. Now we can create our first VM instance. You can name the instance whatever you like. I'm going to leave mine as Instance 1 for now. Double and zone look correct. If you don't know what these are, you can leave them as they are. For machine configuration, select Compute Optimized and select C2 Standard 4. This allows us to have the recommended specifications for running a block producing node on the Mina network, specifically 4 CPUs and 16 gigabytes of memory. Next, let's change our operating system. Go to the boot disk section and change the boot disk that we're using. Under the operating system dropdown, we'll select Ubuntu. And under version, we'll select 18.04 long-term stable. Let's also upgrade our disk to have 50 gigabytes of memory, just in case. When you're done, click the select button, and then you'll be taken back out, and then we can add networking configuration. For now, let's expand the networking options, and under the networking tab, in the network tags input, let's add the Mina node tag, which you can do by typing Mina node and then space. We'll use this later, so don't worry about it for now. Let's go ahead and create our instance. It might take a couple of minutes for Google to get our instance set up, so while we're waiting, let's set up some firewall rules. Firewall rules are configurations that tell Google how to allow our machine to communicate with the outside world. For the Mina node, we're going to need to add a couple of special rules. So let's create a new firewall rule. For the name, let's call it default Mina node. Default except Mina. We can leave most of the options as default, making sure that we check that the direction of traffic is set to ingress and action on match is allow. For the targets, we're going to specifically specify the Mina node tag, which we used earlier when setting up our first virtual machine instance. We're going to want to match against all IP ranges, so we'll use this special qualifier to let the firewall know that we want all IPs to match. Next, we'll set the ports for TCP that the daemon will communicate on. These ports are 8301 through 8302. Now that we've set up our firewall rule, we can create. Let's navigate back to our Compute Engine virtual machine instances. And you can see that our instance has been set up and is ready to connect. In the next section, we're going to connect to our virtual machine instance and install all the necessary node software to run a Mina node and connect to the network. Now that we've set up our virtual machine instance, we can go ahead and connect to it and install the needed software to run a node. While we're at it, we'll also generate a new key pair and submit it for inclusion in the next testnet. The first step is to connect to our instance using an SSH terminal. You can do this using the SSH button under the Connect column. This will open a new window that will open an SSH terminal that connects us to our instance. It takes a couple of minutes for the SSH keys to transfer into the VM, so be patient while you wait. Once the terminal opens up, the first thing we want to do is update our package manager. You can do this using the sudo apt update command. Next, we need to install the O1 Labs package repository. To do that, we need to install a couple of helper libraries that allow the package manager to read from our repository. These packages are the apt transport HTTPS package and the CA certificates package. Once you've installed these packages, you'll need to add the O1 Labs repository to your package manager repositories list. We can do this using the echo command by writing the following contents to the sources file. First, we'll provide the name of the repository, which is http packages.o1test.net. We'll want to use the unstable release and the main repository. Next, we're going to output the contents into the etc apt sources.list.d/o1.list. Now that we've created the package repository file, we need to update our package manager again so that it can read the latest packages from our repo using sudo apt update. Great. Now that the packages have been loaded into our package manager, let's install the Mina generate Keypair utility. First, we'll need to install the helper library libgemalloc. To do this, use sudo apt install -y libgemalloc1. Now let's install the Mina generate Keypair package. Great. First, let's create a folder for our keys to go in. I'm going to create a keys folder in the home folder of my instance. This has created a new keys directory inside of my home folder. Now we can use the Mina generate Keypair command to output a new Keypair file. First, we need to pass in a priv key path. And for the key path, I'm going to use keys/mywallet. You'll be prompted for a password. Make sure to write this password down or store it in a password manager such as 1Password. Even though this is a testnet, these keys are very much real, and if you forget or lose the password, you will be unable to access the funds inside of these keys. So make sure that you take note of this password. Great. As you can see, the Keypair tool has generated a new public key private key pair with the public key that is shown here. You can see these files inside of the keys folder. My wallet contains our private key, and my wallet pub contains our public key. If you want to remember your public key, the way to do that is to see the contents of the mywallet.pub file. You can do this with the cat keys/mywallet.pub. and it'll tell you again what your public key is. Make sure to keep track of these key files, because if you lose them, you will lose all the funds that are connected to the wallet. Now that we've generated our key pair, we want to make sure that we submit this public key for inclusion in the upcoming testnet. If the next testnet has not launched yet and the submissions are still open, you should copy this public key and submit it in the testnet sign-up form that is available on Discord. You can see the link to join our Discord in the description below this video. Next, we'll show you how to set up your node to connect to the actual Mina Testnet. If we don't have a running testnet at the moment, we can go ahead and close out of this terminal, and we can shut down our instance. Shutting down your instance is a good idea to save on costs while the testnet is not running. You can see that the instance is still running with this green check mark. If we want to suspend the instance, we can click the suspend button in the top menu. You'll see a pop-up that lets you know that this will preserve its running state and keep it in a sleeping state, similar to closing your laptop. This is exactly what we want. So let's suspend the instance for now. Now that we're ready to connect to the network, we'll need to make sure that our VM instance is online and running. You can check this by seeing if there is a green check next to your instance in the Google Cloud Platform. If this isn't the case, you'll need to select the checkbox next to your instance and select Start/Resume. This will start your instance back up. Once you see the green check mark, we can go ahead and connect an SSH terminal and start our node. Once the terminal opens up, we'll first want to install the latest version of the Mina daemon. To make sure that we're installing the latest version, make sure to check the Mina protocol documentation page, which is linked below in the description to this video. Once you go to the documentation page, you can go to the Getting Started page. Under the Getting Started page, scroll down to the Ubuntu 18.04 section. If you've previously installed a version of the daemon, you can remove the previous version using these commands. We've already added the repository to our package manager, so we can go ahead and skip this command and go straight to the very last command, which gives us instructions on how to install the Mina daemon. I'm going to use a pre-release version of the daemon for the purposes of this tutorial. So I will run sudo apt install -y Mina Testnet posake medium curves. Again, double check that the version you use matches the documentation page. Once the package has been successfully installed, we'll need to download a couple more configuration files to make sure that we have everything needed to run our daemon. The first file we'll need is the latest Genesis ledger. This will be available also on the documentation, so make sure to check there. You can see the contents of the file here. It largely consists of account balances and account configuration at the beginning of the network. We'll copy this URL and use the wget utility by passing the -O flag and specifying daemon.json as the file that we want to download it to. Paste the URL and hit enter. Next, we'll also need to download the peers list. We'll download this to peerlist.txt. This list can also be found on our documentation site, or you can ask on our Discord if you can't find it. Again, we'll copy the URL and paste it into this command. Now that we have all of the files that we need, we should also make sure that we've set up our keys correctly so that when we're trying to run our block producer, everything works correctly. To do so, run the following chmod command. chmod changes the permissions of the files on our system. Changing them to 700 only allows these files to be read from by our user and not any other users on our protocol, on the system. This is only extra security. Provide the keys folder and hit enter. Now that we've set up the permissions correctly, let's export the key path as an environment variable. We'll use the export key path command and set it equal to $home/keys/my wallet. Next, we'll also need to provide the private key password. This is the private key password that you set up when you created this Keypair earlier in this tutorial. Make sure that you provide the exact same password or else the daemon will crash. Another thing to note is that we are still in the process of transitioning to our new brand. So there are times that you may occasionally come across instances of Coda where they will eventually change to Mina. So make sure that you check back to the documentation for the latest up-to-date commands. At the moment, we still are using the Coda priv key path argument. Here is where you provide your password. Now that we've set up all of our environment variables, we can start the daemon. The command to start the daemon is coda daemon, and then we'll pass in the peer list that we downloaded, peerlist.txt, the config file, which we downloaded, which is daemon.json. We want to generate the Genesis proof, so we'll set that flag to true. Set log to JSON and log level to debug. This will help us if we need to report any crashes to the O1 team. Next, we'll need to provide the block producer key. The block producer key is set by the environment variable that we provided earlier. Now we'll pipe this command through the coda log proc utility. This parses our logs, and then we can output them to the coda logs.txt file. At the end of this, let's provide an ampersand. This will cause this process to start into the background. As you can see, the command is now executing and our node has started to sync. This can take some time on the initial run, as we need to download some of the Genesis proof files, as well and staking keys, as well as connect to other peers on the network. So it's best to give it about 5 minutes before checking back. Let the command run, and then I'll see you in a moment. Once your node has been running for a few minutes, you'll start to see a lot more log messages coming through. This indicates that we've successfully connected to more nodes and peers on the network, and we are trying to sync to the state of the network. To check the status of our sync, we should open up a new terminal. To do that, go back to your Google Cloud Console and open up a new SSH terminal. Once the terminal opens, we can use the coda client status command to check the status of our client. As you can see from the output of this command, we have synced to a portion of the blockchain, but we're still in catch-up, which means that we have not yet got to the best, highest block point yet. A good metric to check is to see what the best tip consensus time is, which is the highest point that we've synced to, and consensus time now, which is the current time in the consensus network. As you can see, we're at 1609 out of 2217. You can keep running this command occasionally to check the status of your node. Once the status switches to synced, you'll eventually then be able to start producing blocks and sending transactions on the network. At this point, you should log on to our Discord and use our faucet or message our community and ask them to send some funds to your public key. You can then use the Coda client balance commands to check the account balance of your public key. Congratulations connecting to the latest Mina Testnet, and best of luck in the testnet challenges. I'll see you next time.